If I were to ask you, what does a 17-mile tunnel buried 300 feet below the ground that's colder than anything in the solar system and also contains one of the emptiest environments we've ever recorded, how would you answer? Go ahead, put it in the comments. I'll wait. If you said to smash tiny particles together at almost the speed of light, you are spot on correct. And also, thank you for watching the first three parts of the series. Yes, after 14 years of design and construction at a cost of about $13 billion, the Large Hadron Collider has been running very small destruction derbies since 2008. But what exactly happens when two particles collide at such an obscenely high speed? Well, it goes boom, clap, the sound of my heart, the beat goes on and on and on and on. Sorry, that song's a total earworm. Anyway, weird things start to happen. For a fraction of a second, the energy from that collision is concentrated into an itty bitty space, an unbelievably small space. How much energy exactly? A whopping 2.2 microjoules, which is enough to power a mosquito. Although lately it does seem that all the mosquitoes around here are powered by O positive blood. But bear in mind, that's just two particles colliding with each other. The LHC is sending hundreds of trillions of protons crashing into each other through the air. This works because Einstein showed us that energy and matter are all relative. Lee. Thank you. Thank you. I'll be here all week. Don't forget to tip your waitress. Now, under the right conditions, energy can become matter. So when these protons collide, entirely new particles can suddenly appear. These collisions, they occur every 25 nanoseconds. To put that in perspective, what you see on TV is typically somewhere between 30 to 60 frames per second. I'm filming this right now in 30 frames per second. Most humans can see the world at about 100 frames per second, some people up to 200 frames per second. But this disappearing act happens at almost 4 million frames per second, so way quicker than the human eye could even dream of perceiving. So how do you observe something that fast? You don't. You CSI it. Scientists are able to examine the debris left behind from these collisions and reconstruct them, much like a CSI would take bullet fragments and try to reconstruct the bullet. CERN utilizes these enormous detectors. Among them are ATLAS and CMS, and their purpose is to record the aftermath of these collisions. And by studying these millions and millions of collisions, scientists have been able to make one of the biggest discoveries in modern physics, the Higgs Boson particle, otherwise known as the God particle. But more on that in the next episode. And also, we're sadly coming to the conclusion of the Large Hadron Collider series. So if you guys have anything you're curious about and want to know more about in the world of science, put it in the comments and maybe I'll choose yours to do the next series on.